Okay, we're starting chapter 11, and guess what? It's all about circles. So usually the first section in a new chapter is pretty easy, and I agree that this is pretty simple, but there's just a lot of information. So let's start off with just the warm-up, see if you can do these questions and get them correct. And it's really important that you know that for horizontal lines like h, it's always going to be y equals whatever it is. So it passes through 3, so y equals 3. And for vertical lines like FG, vertical lines are always x equals whatever number it is. So since it passes through -2, it's x equals -2. This is important because we're going to be writing some equations today. Okay, but we're going to start off with identifying tangent, secants, and chords. These are all important vocabulary words about circles, and we're going to use properties of tangents to solve problems. So we have lots of vocab in this chapter. Interior of a circle, exterior of a circle, those are things you probably should know already. But chords, secants, tangents, point of tangencies, that's all probably going to be new. Congruent circles, take a guess at what that means. And then concentric circles, tangent circles, and common tangent are all probably words that we're going to have learned you haven't seen yet today. So you're going to learn it today. Okay, cool. Circle, the earth is a circle, pretty cool stuff. Okay, interior, exterior of a circle, pretty straightforward. A chord, this is important vocab. Chord is a segment whose endpoints lie on a circle. So any line that touches one part of a circle and continues on to touch another part of the circle, that's called a chord. So it's really important that you write down that the diameter is an example of a chord. Now, all chords are not diameters. For instance, this is not a diameter. Remember, diameter goes through the center of a circle. So this would be a chord. A secant is a line, not a segment, a line. That means it goes on and on and on and on, and it intersects the circle at 2 points. Okay? And a tangent is a line that intersects it only at 1 point. And that 1 point where it does hit it is called the point of tangency. So tangent hits it once, secant is a line that keeps going on and hits it twice. A chord is just part of a line, just a segment, and it hits it twice. Okay, pretty straightforward. First part, super easy. You're just going to, name all these things. So all the chords in this picture, well, KM is a chord because it hits it once and twice. Let's see what other ones. JM is another one. Hits it once, hits it twice. Secant hits it twice and keeps going. So these are segments, these are lines. So you would write it JM like this. I know this is all the way back from chapter 1 in September. It's been a while. So it's a line, it keeps going, and it hits it twice. So JM, and make sure you have the arrows. Tangent hits it only once. You can't say HM. M is not a point. So you literally have to write out line M. You cannot write it like this. Not okay. Remember, you need 2 points to make a line. Okay, and this one's italicized, so that's why you can write it line M, not line H. And then the diameter, we already talked about it, it goes through the center, and notice they write circle L, and they tell you, they name a circle by the point. So you can't write circle K, because K is not the center of a circle. So circle L means that L is the center of a circle, KM goes through it, so the diameter is KM, and that's it. Radii is half of the circle. I'm sorry, half of the diameter, so there's lots of them. We have KL, we have LM, that's a radius, that's a radius. Another radius is JL. Let's see, JL, is there any more? 1, 2, 3, I think that's it, just 3. Okay, so make sure you have the vocab down, answer this slide, and we'll check it when I come back on Monday. So what slide is that? Slide 10. Okay. Some more vocab. We have congruent circles, or circles that have congruent radii. So they have the same radius, and that means it's the same exact circle. If you cut it out and put it on top of the other one, it would be exactly the same. Concentric circles are coplanar circles with the same center. So it looks like, it reminds you of like a dartboard. Okay, they have the same exact center. They're just not congruent, so one's a little bigger than the other one. Two coplanar circles that intersect at only 1 point are called tangent circles. So tangent means it hits at one point. So tangent circles means they touch only once. So here's where they touch once, or it could look like this, where they touch once right there. Okay, internally, tangent circles means one's inside the other one. Externally, tangent means it hits, they're both outside each other. Whoops. Okay, so the second thing you're going to be doing is writing equations. So it's find the length of each radius. Guess what you can do? You can count. This radius is 1.5 units. So the radius for circle S, the radius, oops, equals 1.5. And the radius for circle R, I don't know why this is radius, equals, let's see, 1, 2. Okay, that's easy. Found the length of each radius. Identify the point of tangency. That means where do they hit each other? They hit each other right here. So the second thing you're going to say, point of tangency equals, and you're going to name that coordinate point. So 1, 2, it's at -2, 0. Remember, this first one's always your x, the second one's always your y. And then let's see. And write an equation of the tangent line at this point. So if you imagined this line is right here, this is a horizontal line, so it's y equals, the line will be y equals 0. Okay, if it was vertical, remember it would be x equals whatever. This one would be x equals 3. But they just wanted this one, so that was y equals 0. Okay, try, do you want me to do another one for you guys? Try this one, see what you get. No, that's the same one, isn't it? Yeah, it is, sorry. Try this one. This is the second one you're going to try. This is slide 14. Okay, I'll check it tomorrow. Okay, a common tangent is a line that is tangent to two circles. So these are one way you could think of common tangents. It hits circle A only one time, and it hits circle B only one time. That's what the word tangent means. Same with line M. It hits it once here, hits it once around here. So they are common tangents. But you could draw common tangents like this or like this. Okay, this is still, P is still a common tangent because it hits A once here and it hits B once here. So you can draw it like this, or you can draw them like this. Okay? Some more vocab. I'm sorry, some theorems. If a line is tangent to a circle, then it is perpendicular to the radius drawn to that point. Super, super important. And this is how you would write it in a proof. Yes, we're not done with proofs. You'd say line tangent to a circle, therefore the line is perpendicular to the radius. Okay? So, super important. This is going to help us out with the word problems we're doing next. Where is it? Come back. There it is. So whenever you have a tangent, if you draw AB as a radius, it's always going to be perpendicular. Okay, so here's my circle. Here's a tangent line. You know that if you draw a radius to that point, it will always, always, always make a right angle. Okay, and then the corollary to that, or the reverse of that, the converse of that, is if you know you have a perpendicular line to the radius, that means that line has to be tangent. Okay, so these are just the same thing. One's just saying that it's a tangent, so it's perpendicular. The other one's saying if it's perpendicular, then it has to be a tangent. Meaning it hits it only once. Okay, the reason why that's important is we had problems like this before, and we're going to go back and do it again. Early in its flight, the Apollo 11 spacecraft orbited Earth at an altitude of 120 miles. What was the distance from the spacecraft to Earth's horizon rounded to the nearest mile? So what we're looking for here in this paper, in these problems, when it says altitude is 120 miles, sometimes I'll give you a picture and sometimes I won't. So this time I'm being nice and I'm giving you a picture. They're talking about this. This is the altitude right here. Okay? And I'll usually tell you what the radius is. In this case, I'll give you 4,000 miles. And we want to know what's the distance to the horizon. So we're looking for this line right here. Okay, the reason why that's important is this is a tangent line right here. If you extended it on, it only hits the circle at one point. And why that's important is because this is the radius, and it's right angle, which means we have a right triangle. I know some of you guys were excited that we were done with triangles, but we're not. We will never be done with triangles. To figure out what this is, what x is, what we're going to do is we're going to do Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. But hold on for just a second, because some people are going to put 120 is the hypotenuse. 120 is part of the hypotenuse. This is another radius to the circle. So if this is 4,000, that means this has to be 4,000. So really the hypotenuse is 4,120. That's C. So we have x squared plus 4,000 squared equals that. And now you can solve and figure out what x equals. Okay? Fun word problems. All right, we're almost done here. I know there's a lot in this section. Moving on, some more theorems. If you have two segments that are tangent to the same circle, I call these cone heads. They're going to be congruent to each other. Okay, so if you have a circle Here's circle A. Awesome. And we have a point right here. Let's say this point. And I can draw a tangent on this side of the circle. I could draw a tangent to this side of the circle. Tangent meaning it only hits it once. There and there. These two have to be congruent to each other. Okay? You could call it the cone-head theorem if you want to. But if we're going to use it in the proof, you'd have to say two segments tangent to a circle from same point, then the segments are congruent. That's how you would write it in a proof. I prefer cone-head theorem. I don't know why they haven't published this yet, but apparently this is how they're going to write it. Okay, these ones are super easy. I tell you HG and HK are tangent, meaning it hits the circle only once. Find HG. We know that these two are congruent to each other, so guess what you're going to do? You're going to set them equal to each other. You say 4 plus 2a equals 5a minus 32, and you're going to solve for a. So I'm going to subtract the 2a, add 32, add 32, and I get that 3a equals 36. So that means a equals 12. And guess what? Some people are going to stop there. Don't. Go back and read the question. Find HG. So you're going to plug it in. Since they're congruent, it doesn't matter which one you plug it into. But I'm going to follow the rules and plug it into here. So 4 plus 2a, a is 12. You're going to get 24 plus 4. And your answer is 28. Okay, so these are kind of easy questions. Same thing over here. Go ahead and try this one. This is the third and last question I'm going to give you for your video. Okay, just to go back, so do that last one, that third problem. And then I want to go back to the vocab. I want to make sure you know all the vocab words. If there are any questions, you can ask them tomorrow or Monday in class. Thank you. Yay, circles.